There is so much about quantization. Do you understand it? What is GGML, GPTQ? This video is going to explain.
Let's learn about weights in neural networks. Weights are the parameters in neural network that determine how the network learns and makes prediction. They are actually real numbers that are associated with each connection between neurons in the network. The weights are what allow the neural network to learn the relationships between input data and the desired output data. So in a neural network, if you take a neural network, each neuron receives input from another neuron, and the input from each neuron is multiplied by the weight, and the sum of all the weighted inputs is then passed through an activation function. And the activation function ultimately decides or determines whether the neuron will fire or not. Initially, the weights are randomly initialized, but as the training process goes on, the weights are optimized and adjusted based on the optimization that you have selected. And this is kind of the foundation of a technique called backpropagation. Backpropagation lets you optimize and change the weights in such a way that you can minimize the error. Now, how are weights related to quantization? Now, when these weights are stored in the neural network, that's what the model is. You call it a model weight. So now when these weights are stored in the neural network, it can be with different precisions. So you could store these weights as a 32-bit floating point, or you could store this weight as a 16-bit floating point, or even could be an 8-bit floating point, or 8-bit integer, or a 4-bit integer. So when we talk about weights as numbers, we generally call it a number, but this number under the hood in computers could be of different precision and could be of different data type. And based on the data type or based on the precision, a lot of things change, including the amount of time this neural network takes for inference and also the size of the neural network, ultimately the model in itself. So just to back it up, if we say something as a model, the model is nothing but a neural network with its weights. So the model is going to be huge when the weights are stored in a higher precision, or the most precision, like the most accurate number representation of that floating point value. But the model's weight will come down as you reduce the precision. That is where we have got a very interesting technique that comes in, that is called quantization. Quantization in neural networks is the process of reducing the precision of the weights, biases, and activations of a neural network in order to reduce the size and computational requirements of the model. This can be done without significantly impacting the accuracy of the model in many cases. I mean, when I say quantization, that's the first thing that might come to your mind. Hey, like you're going to reduce the precision of the weights. What kind of impact it is going to have with the model accuracy? That's a very good question. And also quantization happens at two different places. One, it could be a post-training quantization, or the other one could be a quantization aware training. What we do mostly these days, like the bloke with GGML and the GPTQ models, are post-training quantization. What is a post-training quantization? Post-training quantization is the process of quantizing a pre-trained neural network, and this can be simply done by rounding off weights or activations to a lower precision. But this can also lead to some kind of accuracy. So in the post-training quantization, you might take a model that has got, let's say, floating point 16 accuracy precision, and you can convert into a 4-bit or an 8-bit integer. By doing this, you are quantizing the model. You are quantizing the model in such a way that the weight of the model reduces, the size of the model reduces, and it also improves the performance of the model in terms of the hardware that is required to run it. But this can also lead to loss in accuracy. Hope now the quantization part is clear. Again, just to back it up, a neural network is a bunch of numbers stored here and there, and it matrix multiplication. Numbers are stored in the form of weights, biases, and activations. And when these numbers are stored with higher precision floating point, like 32-bit floating point, these models take a lot of size, and these models also require more computation when the models have to predict. That's what we call inference. So by reducing the size of the model, or by reducing the precision of the model, we are reducing the size of the model, improving the model more performant in lower computation, and the model is also going to require less compute and lesser power to do the matrix multiplication and all the. This can also lead to accuracy loss. Now, with all these things in mind, the two popular model types that we see post trained quantized models are GGML and GPTQ models. Now, what are these models? So GGML and GPTQ models are quantized models in a way to reduce the models and also reduce the computation requirements of the model by reducing the model weights to a lower precision. Now, what are the key differences between GGML and GPTQ? GGML models are optimized for CPU while GPTQ models are optimized for GPU. That means GGML model runs faster. The inference speed is faster on CPUs and GPTQ are faster on GPU. The inference quality is said to be similar, but I read a blog post or I read a Hugging Face community article where the bloke said during their experiment with GGML and GPTQ scored a little bit lower than GGML, but I don't have any benchmarks to prove that. But anyways, just keep in mind that GGML and GPTQ are ideally supposed to have a similar inference quality. The model size, the GGML is supposed to be slightly larger than GPTQ models, and both of these models are compatible with Hugging Face transformers, which means you have got like easy way to run these models. In general, the thumb rule is if you have got a CPU without any NVIDIA GPU, use the GGML model. Or if you have got an NVIDIA GPU, even if it is not like most powerful machine in the world, you can use GPTQ model. And I guess this helps you in understanding all these things that people are discussing these days about GPTQ, GGML, quantization, reducing the model size. If you have got any questions, let me know in the comment section. Otherwise, see you in another video. Happy prompting.